Good morning, everybody. My name's Jason Fox. I'm the Senior Technical Evangelist at the FIWARE Foundation, and we're running a series of Wednesday webinars. And the subject of today's webinar is NGSI-LD IoT Agents, which is a lot of acronym in one go. But let's try and find out what that actually means. Okay, so what are we going to talk about? We're going to talk about what, briefly review what is an IoT agent, why do you need them, and how do they work with NGSI, NGSI being the next generation service interface. Now, there's an extension to NGSI called NGSI-LD, which is to do with linked data. Those of you who are familiar with JSON should know that there's an extension to JSON called JSON-LD, which is also JSON with linked data. And obviously, the NGSI interface is based on a JSON format. So it's not surprising that we're playing follow my leader here. And what we're trying to do here is we're kind of trying to get data from a device, a measure, into an NGSI-LD system, and why we might want to do that. So we're going to talk about NGSI-LD measures, which are coming up from your IoT device through your IoT agent into your context broker and beyond, and also the reverse, where you can do an actuation in NGSI-LD, saying I want to do something in the real world, and potentially get that to go down the system, go down to the IoT agent, and cause something to happen at the device, which is done through currently through registrations, though may change to subscriptions. The main section is not much has changed between NGSI v2 and NGSI-LD. It's an evolution. So the main section is to do with how you provision the devices and what the differences are when you are provisioning NGSI-LD devices as opposed to NGSI v2 devices. And the important points there are to do with context, metadata or property of properties, GeoJSON, and so on. And finally, we'll do a little bit on how to have a system which includes both legacy or non-linked data systems, NGSI v2 systems, with an NGSI-LD context broker. How can you combine them? What strategies? What tips? Why you'd want to do what? Okay, so what is an IoT agent? This is effectively a repeat of one of the very early Wednesday webinars. You can get much more detail here, but just in case some of the audience are unfamiliar with this, we'll briefly go over what an IoT agent is. IoT agents overcome a common problem in the IoT domain, and that is have my I want to get this through to a common format, and the common format being NGSI, either NGSI v2 or NGSI-LD. And I want to have a system that will work regardless of what the device is. This is the whole interoperability part of FIWARE, in that there needs to be a translation layer, basically. And not only is translation required, but I don't care if I'm making a NGSI request, whether my device is connected through OPC UA or connected through MQTT or HTTP or whatever. That is completely abstracted out. I don't care. It's not my problem. I'm just make a request, something happens in the real world, or vice versa. So that needs to be moved out of the system somewhere. And then the third point being that data may be in a restricted format. It could be, say, a byte within a data stream, or it could be called something strange or unusual in the stream, something short like C, rather than actually having a proper name like count, or indeed an NGSI LD JSON-LD URI, which is even longer. So we need to be able to map the data in a meaningful manner. Now, the nice thing is that if you have a device which can talk to an IoT agent, so if you've got a device which can say talk JSON over HTTP or ultralight over HTTP or what have you, that is automatically a FIWARE ready device. Okay, it still needs to be reviewed within the FIWARE marketplace, But the point being is that it can plug into a FIWARE system. It is FIWARE ready. Now you can obviously most of this stuff is going to be common across the multiple agents. You're going to have one interface into the context broker. You're going to have one way of working out how to provision your devices. So we need to. There is a library, which means you can add support for your own agent. And there is, of course, the alternative. There are obviously FIWARE is flexible in this in the respect. You could have a device which does what I'm going to show you today directly on the device. The device could be clever enough just to do what is effectively an NGSI-LD upsert at the right time in the right format, and you don't need an IT agent at all. So you could actually go device direct to context broker. Link data. Now, it's not the case that NGSI-LD is the next version of NGSI. It's not called NGSI v3, it's called NGSI-LD. This is because it is an evolution of the existing interface, and therefore it will lie next to the existing NGSI v2. NGSI v2 is not going away. NGSI v2 is basically JSON done right with various bits of REST done right. Okay, so but the problem we have is that if you want to start sharing data across organizations, and I'll give a couple of examples in the next slide. If you want to do that, then you as a developer can't rely on the other organizations to be following the same data format as you have. You have got to somehow ensure that the data that is passed through the system by computers. And the problem is that organizations are run differently. Organizations have different people developing their systems. So we need to have a system which allows us to share data from over barriers in an efficient manner. And this is what JSON-LD does. JSON-LD says, okay, rather than saying I've got an attribute called temp for temperature, and you've got an attribute called T for temperature, or someone else has got an attribute called temperature for temperature, you can assign a long name, a URI, full-length URI, which is in common. So it doesn't matter that I'm calling it one thing, you're calling it something else. Within the computer, within the analysis, it will be able to retrieve the actual URI. So they will have a common URI. The temperature is a full URI for temperature, and therefore computers can understand what's going on. The classic example of this is ratings. If you ever go onto a search engine, and you'll find there's a star rating for a product you want to buy, or it'll tell you whether it's in stock or not. And the reason why that works is because there is a little bit of JSON-LD attached to the web page saying that not only have I got an attribute called star rating, but that star rating is really this long URI, and therefore a search engine is able to read that and say and display a little set of stars. So here are a couple of examples. Whenever you're thinking about linked data, you've got to think about data barriers or barriers. Now, they might actually be national barriers. So, for example, cross-border tourism. If you are trying to do tourism in the south of France, next to the Italian border, the authorities in Italy are probably going to be using a completely different system to the authorities in France. It's probably been purchased centrally, let's say. But it also is the case that there are barriers on a much more local level. If you take the case of local authorities, the boundaries for local authorities who are potentially working independently could be anywhere. So you could have a situation where you've got a car park which is perfectly valid for a city, but it just so happens to be on the other side of a administrative border. And if you, unless you are in a position where you are able to read their data as well as your data, then it doesn't exist in your map. And therefore, you have more congestion in the town because no one's going to the Augustplatz car park because I'm unable to read that data because it's got not in there. Another good example of this is where you end up with, say, citizen scientist projects, where you end up with people having their own devices and connecting their own devices to create data for the common weal. And that means that how are we going to be in a position to know what they have called that data? How can we ensure that our data works? Now, obviously, where possible, you try and promote common data models, but this may or may not be entirely the case. Maybe they've already called it something, and therefore you can you're able to get these things to align on this URI level, so that we're all happy and ready to go. Okay, so NGSI agents. Configuring an NGSI agent is very, very similar, as you would expect, to considering a normal NGSI V2 agent. There are up to 4 additional parameters which are required. Some of them are mandatory, but others you might or might not need. Now, normally when you are configuring an IoT agent, it will either be in the config.js file or it's done by environment variables. Obviously, they are equivalent, but you can just set up a context broker, which is default NGSI V2, and add an NGSI version attribute into the config.js saying LD. You can also, there's another alternative, is you could actually put the value as mixed, and if which means that you would actually on provisioning, you would actually say whether it's V2 or LD for the actual individual device. However, that's more complex. There are headers, the FIWARE service header, the FIWARE service path, which have been traditionally used to support multi-tenancy. Now, within the NGSI-LD specification, these have been given slightly different names, but there is now a hierarchy for creating these or working out what these values are. So you'll see if you've got one called FIWARE service, then you'll see if you've got one called NGSI-LD tenant. Then you'll, if neither of them exist, you can actually use these fallback tenants. Now, the most important bit and the only really mandatory bit for linked data is that you must have a linked data context. Once again, there are previous webinars which have detailed what this is, but this is effectively an address book. It is saying, where do my long names match to my short names? Now, this file, or possibly an array of files, should be made publicly available. I would also suggest that you actually have 2 copies. I would personally use one within my system and also offer a public file for the other authorities that wish to use my data. Because if you're in a situation where you have a closed system, great, I don't need to go out into the internet to get hold of this thing. Okay, it will be cached to find out what the long names, short names are, but other people will want to know it. Typically, you would have a context which consists of the core context, which is the URI etc org core context JSON, plus your own stuff. Now, the core context is common. This defines what the how NGSI works in linked data syntax, but the other one is entirely up to you. The core context is not very long, but it gives you a series of terms which are non-negotiable, effectively. There will be definitions like point or polygon or geoproperty, which are already defined by authorities. So, for example, GeoJSON has got an NGSI-LD, the JSON-LD specification. Therefore, a point, which is effectively a first term attribute in NGSI, you can use GeoJSON terms directly, is going to be called point. Point is a point. Polygon is a polygon. So these are values which shouldn't be overwritten. Most of them are either defining your structures, or there are things like context source notification, context source registration, which are defining the various operations of NGSI. On top of that, there are a few things which are defined for common goods, such as location, because obviously you want to, if you have a device which is in a certain place, and you want to use this as the default thing for geofencing. And then things like unit code is well defined. These use the UN CFACT codes for the various different units of measure. So there is an agreed international standard as to whether you should call something meter or Celsius or a unity or whatever. And the devices, when you are provisioning devices, you should always attempt to reuse these predefined terms, because that's what the NGSI-LD is all about. It's so that you can actually end up with data and metadata which actually works to your favor. Now we move on to the implementation specific context. That was the second file which I showed. Now, the example which I'm going to show in a bit is based on a smart farm, and you can set a series of key value pairs effectively. Now, there are various different classes of ways of defining this address book file, and you can see normally at the top you start off saying, well, I don't want to keep repeating this URI all the time, so let's define FIWARE, the FIWARE URI, the data models, as something nice and long. And my example one is something use an authority for linked data attributes such as schema.org to say these are schema.org attributes. Second thing which gets defined, which you can see usually got capital letters, and then the attributes. Now, the attributes are every single attribute you want to use as linked data throughout the system. So things like accuracy is going to be property of a property for this system. We might have things like battery level or something more deep, like, you know, what's the OS version of my device. All of these values we've got here are coming from the Smart Data Models initiative, where you've got things like a well-defined names for devices, but equally, where there are already authorities like SAREF, or in the case of heart rate, we've got some random ontology from Perl. You would use those in preference to making them up as your own. The idea is that we come up with a common book of common names for my attributes. So it's more a case of, what does this thing actually do? This is really a temperature attribute, therefore it really should be aligned with one of the big address book providers to say, yes, this is a SAREF temperature. Now, you can, of course, add your own stuff in, and example up in the top left is my my own random URI for adding in my custom app attributes. If possible, you wouldn't need to do this for devices because devices are well defined, but it is possible. If you fail to define a term in your app context, it will fall back to the default context. If we look at the if you look at the core context in detail, it will set the app vocab, default app vocab, to default context. So it's still got a URI regardless of whether you give it one or not. It's just it's going to be automatically aligned with Etsy rather than with your organization, and therefore you should be in a position to do what's necessary. Okay. NGSI-LD measures are very, 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 very similar to NGSI V2 measures. Indeed, this is the same slide as would the same graphic as you would get for NGSI V2. And you take a device reading, device passes up some sort of measurement. It doesn't matter what the syntax is at this point, into the IoT agent. The IoT agent itself must be able to parse that data. In this case, so the ultralight IoT agent will be able to read the data in as ultralight, you have already provisioned a device to have necessary information. So we get hold of the device from our effectively a database. We do the various bits of mapping and we push to the context broker. The only difference here is that final step. That push to the context broker is now pushing to an NGSI-LD context broker rather than a NGSI V2 broker. Now, if you look within the FIWARE catalog, there are currently 3 NGSI-LD brokers out there: Scorpio, Stelio, and the extension of Orion, and this will should work on all 3 of them because that interface is well defined. So it's only all that the context broker is receiving is a structured upsert of entities, potentially including linked entities. Let's go for a short demo. If we're currently starting a simple little Docker Compose, and this is very similar to the Docker Compose which you would see for NGSI V2. You've got Orion in it, nothing Orion LD because I'm using my NGSI-LD context broker. But the important bit's the IoT agent, and the IoT agent has got these additional elements in it to say, I am going to be doing stuff in LD format, and I am going to be using the following context file. As you can see, I've got a file called NGSI-LD context JSON LD, and this is also within my system. It's on the server. You can generate these things. They are there's a little tool I've created to take these from Swagger specifications. But you can see all of these have got well-defined names so that you can get hold of the right state or status or whatever, or temperature or what have you. You can see all those values are in there. Now, having done that, I should be able to get the context from a server. And you can see that somewhere on the internet, I have got a context file which I can get hold of, which is this data models NGSI context, which is the value which I put into that configuration file. So going back to the IoT agent itself, the IoT agent, I'll just send that, is currently on 151 next because the code for this has not actually gone into a stable version of the library. But you can see that it exists, it's out there. I would then need to provision my data. I'll move that down a bit, it's a bit large. And you can see I am in a position where I am doing a provisioning. Now, what does the provisioning mean? Okay, it's got saying I've got this key, which is making sure that I've got the right, I'm getting the right data in, or I'm talking the right MQTT, or what have you, and I'm going into a context broker, and I have here attributes and metadata. You can see for anonymous devices, I am having a beats per minute, which is going to be an animal collar. And it's a property with a heart rate, and it's got the following metadata. Now, the metadata, the classic metadata, which you should be provisioning in a device, is both the timestamp and the unit code. And this is the unit CFAX unit code for beats per minute. And similarly, there are other things we could put in. We could put in a status, you know, whether I'm happy or unhappy or whatever, or we could put in an object like a GPS location. And furthermore, you can add in additional static attributes, which would be passed into the NGSI context broker. So this device is always going to have a category of sensor. Now, category supported protocol, location, status, etc. All of these are in my context file. It just returns as it does normally. To provision an actual device, you can do individual devices. These are named devices. You have to do named devices if you're doing actuators. And you can see that this is a temperature sensor, and it should be fairly obvious. Once again, we've got a type of property, and we have metadata saying that the unit code is in degrees Celsius. So this means for this specific device, we have a unit code of Celsius. On the static attributes, we have a relationship. As you well know, NGSI is all about properties and relationships, and these are keywords, which means I'm going to be a controlled asset for this particular building. Once again, we can send something in, and it takes a little bit longer first time it loads this because it's got to read the at context file. So doing it thereafter is a lot quicker because it doesn't have to store all that stuff. So this is just using a simple ultralight request. This is a temperature of 3 degrees. This should be familiar to anyone who's already been using the ultralight IoT agent. So I send that in, and it should be the case that it follows the diagram which I showed a minute ago. And the context broker, if I then do a context broker request, is saying for device temperature 001, I am getting 3 degrees Celsius. So you can see that that will also work. We could also do the same thing for an unknown device if necessary. Internally, what's happening is as follows. Because I've set the timestamps on within my IoT agent, I am adding in various elements, properties along with my initial properties. So you can see in NGSI v2, I would have had a time instance metadata attribute, and a metadata attribute for unit code or accuracy or whatever else you want to put in. Within NGSI-LD, the well-defined terms in the core context are observed at and unit code, and these just return string values, or rather it's going to be a UTC timestamp for the observed at. This is done automatically under the hood. And you can see the difference is mainly in the header and the at context line. It is no longer application JSON, it's application LD plus JSON, which is the standard for JSON LD. It is no longer the V2 endpoint, it's the NGSI V1, NGSI-LD V1 endpoint, but they're both doing basically an upsert operation. Indeed, it will be doing an upsert operation with the update, so it won't options parameter, so it won't actually destroy your existing data. But this is very, very similar to the existing thing. So this is how a measure goes in. The provisioning, which I just showed you, you can see that you need to have entity types attributes, static attributes, which correspond to the values in that at context. This is where the interplay happens. And it is also a very good idea to follow names such as property or relationship, or you can use native JSON types or GeoJSON types. So you can add in things like float or number, which obviously would be worthwhile for devices. The default, I believe, is for a property as a string, because that is more generic. If you are looking at extending your devices to accept some sort of JSON object, you can give the type of, say, postal address, and it will be created with an at type within the JSON file. So it's a little bit more JSON LD specific if you start doing objects. I would suggest for devices, it's much simpler just to put the use property name or native JSON types. Similarly, as I said, for the devices, it is possible to add additional data. Once again, you have the attributes and static attributes. There is an open PR to add the idea of links, so that I could have done, say, I am a temperature gauge in a building, and it would also update the building itself with a provided by attribute. You can see on the right hand side, it's saying giving you the necessary data. This means that you are then able to traverse the knowledge graph to be able to say, okay, I am building X with temperature 10, but I've received that from a device. That device has got an accuracy of 80%, therefore I can, and so on and so forth. So you can see how you could structure your data to be able to move from one item to another. As I mentioned, GeoJSON is native within NGSI-LD. It is also provisional with NGSI V2, but you could quite easily foresee that you have got different payloads which could potentially hold a GeoJSON attribute. As I'm saying, let's say I'm a tractor in this case, and I want to be able to follow the GPS device of where my tractor is on my farm. Any of the syntaxes on the left-hand side could be used here to represent that, depending on what are the capabilities of your device. Can your device send JSON? Is your device restricted to sending just strings or some sort of binary data? Now, the context broker will receive an upsert of structured JSON if you have provisioned your GeoJSON attribute properties. You can see it's always a type geo property, and it has a value which is consists of the GeoJSON itself, which has got that coordinates, which was again back in that core context. So for provisioning of GPS devices, obviously you'd use location as your the name of your attribute, because that is the default geoproperty within NGSI v2, NGSI-LD. And if you want to set the type to geoproperty or any GeoJSON type. Now, as you can see, within this provisioning, I'm doing either GeoPoint or GeoJSON. These are both possible. And then you need to map the relevant object ID to the attribute name. The object ID is what's coming in. So in my case, if I go back to the previous slide, you can see my GPS is an ultralight string is GPS / very terse lat long or long lat, can't remember which. It's long lat, isn't it? And then it is also possible, of course, if you have a device which had latitude and longitude as separate attributes, to be able to use the expression functionality of the IoT agent to be able to get hold of that information. You don't even need to do this if you're adding in data through the JSON IoT agent, because obviously GeoJSON is JSON, so you can just put the value direct as a GeoJSON point. But you can alias this if necessary. Provided you've put GeoJSON or GeoProperty or one of the values, you could even use line, string, or polygon here, you will be able to get the data converted automatically. Actuations are somewhat different, and the actuation interface is not entirely nailed down yet. The NGSI-LD actuation code is based on the NGSI v2 IoT agent paradigm, which uses registration in the middle. This means that when something happens on the context broker, the IoT agent has registered its interest in saying, hey, I want to be told about that attribute, or that I control that attribute, and there is request forwarding. It will then forward data into my IoT agent, who will say, hey, I know what this lamp is, or I know what this device is, I can deal with it. However, there is a bit of a caveat here, in that the NGSI v2 registration paradigm does not work very well with federations, because the NGSI-LD specification for federations is saying, okay, I will use registrations to say, I know something about this, and I don't actually own this. So it may well be the case that the internal interface here will change to be a subscription-based interface, or indeed there's a proposal to end up with a full digital twin actuation interface as a possibility. This doesn't matter, because of course all this will be held within the element itself, and it's not what's coming from the device is not going to be a problem. All this means is that at some point the interface will need to be the internal interface for the library will need to be updated. This is just a warning. At the moment, this works on Orion LD. How does it work? Well, it works in the following fashion. If I provision a device, I say I have got a couple of commands which need to go on, and I will therefore say, okay, these commands are C-source are effectively registrations. So the command on and off will say, I'm registering device, I'm registering interest for the properties on and off. Now, as you, because this is not necessarily the case, not necessarily required that the you put this into the default context, because it's just being used internally. Okay, so shall we see this one in action? Okay, I have a water sprinkler, and I've got commands on and off. You can see once again I'm saying I'm related to this barn here. It's now sending up the registration. Now, if I go to my my little demo, it should be the case that I can send a command to switch my water sprinkler on, and you should be able to hear that the water is now running in the background. And if I go back to my devices, you can see that the device is now switched on because I've turned it on, and because I've got the off command, I can send water off. That will send something to the command. It will switch the water off, and eventually the sound will stop running. So that is actuation. Actuations hasn't really changed. It's internal to the system itself. So internally, all that's happening is that because I've set a C-source registration, I'm getting a forwarding. I'm forwarding the same request, as you can see, it's from the outside direct to the context broker into the IoT agent, and this uses this multi-tenancy NGSI-LD tenant inside it. If that's not found within the request, it will use the FIWARE service header, of course, but it also has got a backstop for that IoT agent fallback tenant. Finally, moving on to combining NGSI-LD and V2, there is already a third status for the NGSI for the IoT agent. Not only can you receive NGSI-LD data or NGSI V2 data, you can combine the two. You can actually provision using mixed mode, where details are can be found within the documentation of the IoT agent itself. There we go. So yeah, we've got mixed mode as well, and this would enable you to fire some of your data as NGSI-LD, some of your data as V2. All that means is that when you are provisioning, you need to provision an additional attribute saying NGSI-LD version, and that will by default be V2, but you can say, oh, by the way, this particular device I want to send to that context broker as a LD format. However, it may be the case that you have got a it may be the case that you've got NGSI V2 devices out in the field which you want to be able to push to an NGSI-LD context broker. Maybe you want to shadow it. Now, the obvious way to do that would be to create a subscription. You do a subscription with a V2 subscription with an expiry date in the past, and it's the case that because the V2 subscription interface is well defined, you can then have functions which would duplicate your device, copy the entity data, and then return. Similarly, you can shadow the code, shadow device updates, so that we can pass the data on. Now, this is actually the same sort of code as is found within the library itself. If I just show you a quick example, I've got data coming in. I know that it's going to be an array, so I can just do a for each on my data and copy the attribute data. This will do an upsert for the device, and the upsert for the device is just going to convert the data into LD, and you can see it's no matter what I call my attributes, because this is NGSI-LD, NGSI V2 data, it needs to become valid for NGSI-LD. So therefore, it will say, okay, if it's, I'm going to give it a type of property, unless it's a relationship, and then anything else will be converted to the native values. This one hasn't got the GPS stuff in it for simplicity, but you've got, you should be able to get the idea, and it will push the data direct up to a context broker using an upsert. This should now be familiar, because this is what happens when you're actually doing measures. In summary, IoT Agent has now supports basic or experimental NGSI-LD operation. It is still subject to change, but it is something which is worthwhile playing with. Already ported to most of the IoT agents. There will be an official release sometime in the very near future. As I said, some of the internal actuation mechanisms are still subject to change. So it wouldn't. So if you're trying to get your FIWARE system to actually actuate stuff, you might need to be a little bit more patient. It's really not changed. It's got, apart from using the right names like property and geoproperty, you're still doing the same thing as you were doing for NGSI v2. The only important thing is that you must have an app context, and the app context is required for this system. And there is obviously a fallback for that question. So that, in summary, was a whistle-stop tour of what's happening with NGSI v2, moving up to NGSI-LD. And all that remains is for me to thank you for your time and open the QA for any questions. And I hope you have a good rest of your day.